Hi, welcome to this Corbettmaths video. In this video, we're going to go through the video solutions to the Corbettmaths practice questions on the proportionality graphs. If you need any extra help on the proportionality graphs, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 255B, there's a dedicated video tutorial there. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question, question number 1. So question number 1 says 4 graphs are shown below, so we've got graph 1, graph 2, graph 3 and graph 4, and we've been asked which graph shows y is directly proportional to x. So we're looking for y is directly proportional to x. So the graph for y is directly proportional to x will be a straight line graph, and it starts at the origin and it goes up like so. So that'll be graph 2. Graph 2 is y is directly proportional to x. As x increases, y increases, and it's this linear relationship. So for instance, if we double x, we'll be doubling y, and so on. So that is the relationship of y is directly proportional to x. So that's going to be graph 2. So let's write that down, graph 2, and that's it. Okay, let's look at our next question, question number 2. So question number 2 says 4 graphs are shown below. So we've got graph 1, graph 2, graph 3 and graph 4. And we've been asked which graph shows y is inversely proportional to x. So y is inversely proportional to x. So this is y is inversely proportional to x. And whenever we've got an inversely proportional relationship, as one increases, the other one decreases. And here, because it's just y is inversely proportional to x, if we were to double x, we'll be half from y. If we make x 10 times bigger, y become 10 times smaller, and so on. And that'll be graph 4, because as you double x, you'll be making y, the value of y, the height, half of it. Okay, so it'll be graph 4. So that's the one we're looking for, because we're asked to find which graph shows y is inversely proportional to x, and this is the inversely proportional graph here, and that's it. So let's write that down, graph 4. Okay, let's look at our next question, question number 3. So question number 3, we've been asked to sketch a graph that shows y is directly proportional to x. So we've looked at that previously. This is the directly proportional to graph here. It starts at the origin and goes up like so. As you double x, you'll be doubling y. So it'll look something like this. So it'll start at the origin and go up like that. And that's it. So that will be y is directly proportional to x. As you double x, you'll be doubling y. So that would be the graph of y is directly proportional to x. So it starts at the origin and goes up diagonally in a straight line. Obviously, if you were to do a steeper line or a less steep line, they would be fine as well, because actually as you double x, you'll be doubling y, or you double an x, you'll be doubling y. In terms of the steepness of the graph, that'll be whatever the constant of proportionality is, the value of k, whenever you actually find that out. But in terms of the sketch of the graph, that'll be the sketch of the graph they're looking for. It starts at the origin and goes up in a straight line, like so, a diagonal straight line. Okay, let's look at our next question, question number 4. Okay, question number 4, we've been asked to sketch the graph that shows y is inversely proportional to x. So y is inversely proportional to x. So as we double x, we'll be half from y. As we increase x, we're decreasing y. So if you were to make x 10 times bigger, you make y 10 times smaller, and so on. So the graph would look something like this. So it starts off quite steep and comes down like so. And as you double x, the height will be halved. So that's it. So this is the relationship of y is inversely proportional to x. So that's a sketch of that relationship. Okay, let's have a look at our next question, question number 5. Okay, question number 5. So this time we've got 4 graphs. We've been told the 4 graphs below show different relationships between the variables x and y. Now I can spot some of them already. This one here is directly proportional to, so y is directly proportional to x. This one here is inversely proportional, so it's going to be y is inversely proportional to x, so I can spot those two straight away. And then in terms of this graph, graph 1, it looks like part of a quadratic graph, so it could be that y is directly proportional to x squared. It could actually be, depending on how steep it is, it could be y is directly proportional to x cubed, because in terms of the right hand side of that graph, they would look very similar in terms of a curve going upwards. Obviously depends how steep it is. If it's cubic, it's going to be very steep. If it's quadratic, it's going to be less steep. But in terms of these graphs, the options that we see below will obviously let us know which one it is. And this one here looks like that y is directly proportional to the square root of x, because it looks a bit like the square root graph. Y is equal to the square root of x, looks something like that. So it looks like the y is going to be proportional to the square root of x. So let's have a look at our options. So here we've got 4 relationships. Y is inversely proportional to x. Well, we had that one already. This is the inversely proportional one, so that's going to be graph 4. Let's look for graph 2. That's directly proportional to, so y is directly proportional to x would be this one here, so that's going to be graph 2. Okay, our next one, we've got y is directly proportional to x squared. So as I mentioned, directly proportional to x squared looks like this one, so that's going to be y is directly proportional to x squared. It looks like that right hand side of the x squared graph, that parabola. So that's going to be graph 1. And then finally, this one here is y is directly proportional to the square root of x. So y is directly proportional to the square root of x. So that's going to be graph number 3 for that one. And that's it. So our answers are 4, 1, 3 and 2. Okay, let's have a look at our next question, question number 6. So question number 6, we've been asked to sketch a graph that shows y is directly proportional to x squared. So we want to do the graph of y is directly proportional to x squared. So that's going to be the right-hand side of the quadratic graph. It's going to be that right-hand side of the parabola. So it's going to look something like that. So it starts at the origin and curves upwards. And that's it. So that would represent the relationship y is directly proportional to x squared. And that's it. Okay, let's look at our next question, question number 7. Okay, question number 7, we've been asked to sketch a graph that shows y is directly proportional to the square root of x. So we've looked at that previously. We had that graph here, y is directly proportional to the square root of x. So in terms of the graph of y equals root x, that would be this graph here. So it starts at the origin there and then curves upwards like so. So if I wanted to sketch the relationship y is directly proportional to the square root of x, it would start at the origin here and it would curve upwards like so. So that's the relationship y is directly proportional to the square root of x. Okay, let's look at our next question, question number 8. Okay, question number 8. Question number 8 says, shown below is the graph that shows y is inversely proportional to x. So we had that earlier. Y is inversely proportional to x was this graph here. Y is inversely proportional to x. We actually sketched it as well. We sketched it here. Y is inversely proportional to x. So if we have a look here, as you can see here, this is y is inversely proportional to x. I'm just going to write that down. Y is inversely proportional to x. So y is proportional to 1 over x. So it's y is inversely proportional to x. So as x increases, y decreases. As you double x, you halve y, and so on. And the question says, complete the sentence. As the value of x is doubled, the value of y is... Well, that means it's going to be halved, because as you double the value of x here, so as you double the value of x, so as you move across, so for instance, if you're 1 across here and you go across the 2 across, the height is halved. And actually, if you think about it in terms of this relationship, if you've got 1 divided by a number, if you double the number that you're dividing by, so instead of doing 1 divided by 2, which is 0.5, if you do 1 divided by 4, that's 0.25. So you're halving your answer. So if you double the value of x, you're going to be halving your answer. Why? So y is going to be halved. Okay, so let's have a look at our next question, question number 9. Okay, question number 9. Question number 9 says, shown below is the graph that shows y is directly proportional to x squared. So y is directly proportional to x squared. And the question says, complete the sentence. As the value of x is doubled, the value of y is so many times larger. Okay, and we need to figure out how many times larger it is. Okay, so let's have a look at this relationship. We've got y is proportional to x squared, or y is directly proportional to x squared. Now, whenever we're dealing with proportionality questions, we quite often get rid of this proportionality symbol and we put in the constant of proportionality. So if I had this in a question, I would often write y is equal to k times x squared, where I get rid of the proportionality sign and I put in the constant of proportionality. So a particular value that we're timesing by, so maybe 2 or 3 or 10 or something like that. Okay, so let's have a look at this. And what I'm going to do is I'm going to say, let's let k be a certain value. Let's say that k is equal to 5. So let's say the constant of proportionality is equal to 5, because it would still look like that in terms of the graph. So we would have y is equal to 5x squared. And let's see what happens when we double the value of x. So for instance, if x was equal to 1, what would y be equal to? Okay, so if we square 1, remember we need to do 5 times x squared. So order of operations, we're going to square first. I'm thinking back to pi r squared. You square the radius before times it by pi. So if you do 1 squared, you get 1 times 5 is 5. Now if we double that and we say, well, let's double the value of x and let's choose 2. If we do 2 squared, that's 4, and then times 5 is 20. So y would be equal to 20. So as we've doubled x, as we've made x 2 times bigger, we've doubled x, we've actually made y 4 times bigger. So we've actually made y 4 times bigger. And let's check that again. If we double x again, so instead of using 2, let's use 4. Let's double it again and see, does this become 4 times bigger? Do we get 80 here for our value of y? So if x is equal to 4, 4 squared is equal to 16 times 5 is equal to 80. So it is 4 times bigger. So if you've got the relationship y is directly proportional to x squared, if you double the value of x, the value of y will be 4 times bigger. And here I just let k be equal to 5. You could do this question again and let k be equal to 10 or 2 or something like that. But you'll see no matter what, if you double the value of x, the value for y will be 4 times bigger. So it's going to be 4 times larger. Okay, let's look at our next question, question number 10. Okay, question number 10. Question number 10 says the four graphs below show different relationships between the variables x and y. Okay, so we've got these four graphs and the question says match each relationship to the correct graph. So we've got these four relationships. Okay, so let's have a look at the first one. Y is proportional to x, or y is directly proportional to x. So we know that's going to be a straight line starting at the origin going upwards as you double x, you double y. So that's going to be graph 4. This is y is proportional to x, or y is directly proportional to x. So that'll be graph 4. Okay, our next one, y is proportional to 1 over x squared. Because it's 1 over, that means inversely proportional. So this relationship is inversely proportional because it's 1 over. So we're looking for an inversely proportional relationship, and that will have this shape here. As you increase the value of x, the value for y will be decreasing, because here if you're making the denominator bigger, you're going to get a smaller and smaller answer. So that's going to be graph 2, because that's the only relationship here that whenever you increase the value of x, the value for y decreases. It's the only relationship with an inversely proportional to. So that's going to be graph 2. So this one's going to be y is inversely proportional to x squared, and it's inversely because it's 1 over it. Okay, next one, y is proportional to the square root of x. So this is the graph of root x, so it's going to be graph 1 here. This is going to be y is proportional to the square root of x, so it's going to be graph 1. And finally, graph 3, as you can see here, we've got the right hand side of the parabola in terms of that y equals x squared graph. So this would be y is proportional to, or directly proportional to x squared. So it's going to be graph 3. So the graphs are 4, 2, 1, and 3. Okay, and let's have a look at our next question, question number 11. Okay, question number 11. Question number 11 says the time taken to build a school is inversely proportional to the number of builders, because obviously as there's more builders, it's going to take less time to build that school. And it says it's inversely proportional. So I'm going to write that down actually as a relationship. The time taken is inversely proportional to the number of builders, and n's the number of builders and t's the time taken. So if you increase the number of builders, the time taken will go down. So this is an inversely proportional graph. So it's going to look something like this. It's going to come down like so. So as the number of builders increases, the time taken decreases. So that's it. That's our sketch. Okay, and let's have a look at our last question, question number 12. So question number 12 says the distance a ball falls when dropped is directly proportional to the square of the time it's been fallen. And we've been asked to sketch a graph to show that relationship. So here we've got our axes are going across horizontally, we've got time, and going up vertically, we've got distance. And let's write down what the relationship is. We've got the distance the ball falls, so let's call that d, the distance it falls, is directly proportional to, so directly proportional to, the square of the time it's been fallen. So the square of time, so that's going to be t squared. So we've got the d is directly proportional to t squared. And we want to sketch that relationship. So that's directly proportional to t squared. It's going to be that right hand side of the quadratic graph. So we're going to start at the origin, because obviously whenever time is equal to 0, it hasn't fallen at all yet. And then it's going to curve upwards like so. And if we think back actually to question number 6, we were actually asked to sketch y is directly proportional to x squared. And we had that sketch. And this is the same, obviously, we've just got different variables. Instead of x, we've got t. And instead of y, we've got d. And that's it. So this graph would represent this relationship. The distance it falls is directly proportional to the square of time, or t squared. It's that quadratic relationship, like so. And that's it. So in this video, we've gone through the video solutions to the Corbettmaths practice questions on the proportionality graphs. If you need any extra help on the proportionality graphs, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 255b, there's a dedicated video tutorial there. Alternatively, you can scan this QR code. But I really, really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. Thank you so much. Cheers. Bye.